This tutorial will be about titration calculations. So when you're given homework or an exam that asks you to calculate something just like this question on the screen does, it's important to read carefully and realize that the question is about titrations and that it's not about asking you to find just the pH or hydronium ion concentration, which you learned earlier. So how would you know that this question is a titration? Well, first of all, they could use the word titrated or titrant in the question. Another keyword to always look for is neutralize. Generally, when you see that, the question is about a titration. Another thing you can do to help you out in a question like this to figure out what direction to be headed in is to read it and look at all the values that are given. For example, in the question, it says that it takes 12.2 milliliters of a 0.15 mole per liter standard NaOH solution to neutralize 20 milliliters of water sample containing HCl. What is the concentration of the acid? In this case, you're given 3 values and asked to find another. In the chemistry section of Science 30, you only learned one equation that has 4 variables, so that's another hint that you know this is a titration. Once you've figured out that a titration is what is going on in the question, it's important to draw a picture and list all of the variables. So one piece of important equipment that you used in your titration lab was a burette. The burette was the long glass piece that you filled with acid or base. If you remember, burette starts with the B and so does base. So in Science 30, we generally put the base in the burette. The other piece of equipment that you used, besides a pipette, was an Erlenmeyer flask. The Erlenmeyer flask contains the other solution, so in this case, the acid. As well as the acid, you also had to place an indicator in the acid so that you knew when neutralization occurred. So why does neutralization occur? The base is slowly dripped in to the Erlenmeyer flask into the acid until color change. At color change, we know that the acid solution has been neutralized by the base. So now that the picture is drawn, we should probably put our variables into the picture so we know exactly which numbers represent the acid and which ones represent the base. So first of all, the question says if it takes 12.2 milliliters of a 0.15 mole per liter standard NaOH solution. We know NaOH is a base because it has the OH, which is the hydroxide ions. So in our diagram, we're going to put the volume of the base, so we'll call that VB, equals 12.2 milliliters. And it says of 0.15 mole per liter standard NaOH solution in the question. So we also know that the concentration of the base is 0.15 mole per liter, and we'll call that Cb. Really important to read carefully to make sure that it's actually the concentration of the base and not just worded differently and was the concentration of the acid. So if we keep reading the question, it says that the NaOH solution was used a water sample containing HCl. So HCl is our acid because it is the strongest acid in our acid-base table as well. Hydrochloric acid should be an acid that you know for the diploma. So the volume of acid given, so we'll call that VA, is 20 milliliters. And the question is asking us to find the concentration of the acid. So we will put Ca equals question mark. So now that we have our picture drawn and all of our variables listed, we now have to continue on to step 2. So we'll label this step 1. Step 2 is to write out the formula that represents the reaction that's taken place. So here we are mixing an acid with a base. And when an acid and base mixes, it neutralizes, just like it says in the question. And what will be formed is a salt and water. So in Science 30, this equation is enough to represent a neutralization, but if you'd like, you could put the actual formulas of the acid and bases used to write your equation. So the acid used was HCl, the base in the question was NaOH, and if you react HCl with NaOH, a double replacement occurs, and the salt formed is NaCl, and water we write as HOH. If you can't do this step because you're unfamiliar with double replacements and what salt will be formed at the end, it's okay to just write down acid plus base produces a salt plus a water. So after we write down the formula, the third step would be to find the equation that will help us solve this problem. So the one you learned in class is that the concentration of the acid times the volume of the acid, so acids go together, equals the concentration of the base times the volume of the base. Remember, this equation only works when you have one-to-one ratios of acids and bases reacting, which is always the case in Science 30, but might not work in your other science classes. And if you forget this formula, you could look it up in the data booklet, except that it appears in a slightly different form. So if you open up your data booklets and turn to page, oh, hang on, this is on page 10 of the data booklet, so we'll go back here, so it's a little bit bigger. It is on page 10, but instead of CAVA, it says CIVI equals CFVF, so you'd have to put in A's for the I's and B's for the F, but it is in your data booklet if you need it. So back to the question. So now that you have the equation written down, there's two things you can do. You can either fill in the numbers and then solve, or you can rearrange the equation and then solve. So we're going to practice rearranging the equation. So because we want CA by itself, you have to get rid of VA. So the opposite of multiply is divide. So we're going to divide both sides by VA. The VAs will cancel out, so you will get that the concentration of the acid equals the concentration of the base times the volume of the base divided by volume of the acid. Now you can plug in the numbers. So the concentration of the base is 0.15 mole per liter. The volume of the base is 12.2 milliliters, all divided by the volume of the acid, which is 20 milliliters. Now I know writing out the variables and all of the formulas seem like a lot of work, but it's really important because it helps you to realize that you've done your rearranging correctly. For example, the milliliters on the top will cancel the milliliters out on the bottom because anything divided by itself is 1. So what you're left with for units is moles per liter, and you know that that is correct because you're looking for the concentration of the acid. So now you can take out your calculator and put in the numbers. I generally put in the brackets as well because that's exactly how you wrote it, so it'll appear exactly like that in your calculator. So after you divide, you should get an answer of 0.0915. Don't forget the units is moles per liter. So that is the correct answer, but now we have to put our answers into correct scientific notation as well as significant digits. So if we go back to the values that are given in the question, 12.2 milliliters has 3 significant digits. 0.15 mole per liter has 2 significant digits because the 0 before a number is not counted as significant. And the 20 milliliters also has 2 significant digits because zeros after are significant. So if you go by the significant digits, the lowest significant digit is 2. So your answer should only have 2 significant digits as well. So how do you do that? First of all, you can round your answer to 2 significant digits. So that would be 0.09. And because you're only allowed one more digit, the 15 has to round up to a 2 moles per liter. But that probably still isn't good enough for your teacher, and you have to put your answer into scientific notation. So we need to move the decimal behind the first non-zero number. So if we take our decimal and we jump, we have to jump 2 spots to get the decimal behind the first non-zero number. So your final answer will be 9.2 times 10, and because you made 2 jumps, it is -2 moles per liter. And that would be your final answer. If you're not sure if the exponent here is supposed to be positive or negative, any small numbers, so that's numbers smaller than 1, generally the exponent is negative. If you have a large number, for example, a number larger than 1, the exponent will be positive.